All right, today we are going to be reviewing percent error, and then we're also going to talk about simple interest. So we've got a double video going on here. Hopefully we get it all in one. So percent error, you're going to figure out how much your guess was off by divided by the actual amount. So say, for instance, you think Johnny here expects 20 friends to show up at his birthday party, but 25 actually attended. This would be his estimate. And then this was the actual amount who attended. So the difference between the two, and you're like, wait, that's going to be a -5, but we always look at these with absolute value. And then we're going to divide by the actual number who attended. And then you have to multiply by 100 to get it to be a percent. Now, you can calculate percent error with something like this, but typically what happens when we use this is we're trying to see if the error that we got is significant. So anything over a 50% error is significant. So say, for instance, I was working with something scientific and I wanted to see if my measurement was significantly different from the actual accepted value of something. Then I'm looking at my percent error to see if the mistake that I made in my measurement is significant enough to cause a problem with the results that I get. So down below, I want you to pause for a second, and you are going to make some guesses, because when you turn it back on, you're going to take a look at, I'm going to write in the actual answers, and then we're going to do percent error. All right, so I made some guesses there, and this one's talking about Michael Phelps and how many Olympic medals he won, and he actually won 22. So that means I was off by 7. My error was 7 medals. But then I'm going to divide it by the actual amount and multiply by 100, and when I do that, I'm going to get a 32% error, which is pretty high. You're like, 7 is not a very big number, but my percent error is pretty high because the number I was working with was pretty low. My next one over here, M&Ms were actually invented in 1941. So I would set up my equation to look like that. In 1941 minus 1922, I was 19 years off. So when I divide that by the 1941 and multiply that times 100, you're like, well, 19 is a lot more off than 7. But because the number that I was working with was so large, my percent error here actually ends up being less than 1%. The scientific part I was talking about with you, we've got a dot plot down here to kind of show that one. So it says the dot plot shows that measures made by a science class, if the actual mass is a 1.1 grams, what's the greatest percent error among the measurements? And what is the least percent error? So they want the least and they want the greatest percent error. And we're going to round to the nearest tenth. So if 1.1 is my accepted, well, there are some kids that actually got a 1.1. So if they get the actual amount, if I were to do that work, I'm going to get a percent error of 0%. So my least there is 0% because they actually got the right answer. Now my greatest, if I look at a chart like this, my greatest is going to be the one that's farthest away. It doesn't matter if it's lower or if it's higher, it's just the one that's furthest away. So since this is 2 spaces away and this one is 3 spaces away, I know that one's going to have the greatest percent error. So if I do 0.8 minus 1.1 divided by 1.1, I'm going to get 0.3 divided by 1.1 times 100. Which gives me a percent error of 27%. You're like, Mrs. Williams, that is such a small amount, but because the amount that we're measuring to is also very small, that we do have that large percent error. So now would be a good time to go practice some percent error questions, and then you can come back to do the simple interest, or you can keep going. It's up to you. Simple interest we're going to be talking about next. The principal is the total amount of money borrowed or invested, and I think of it as what you started with. So it's the amount of money that you started with. And simple interest then is money that is paid, and I also think of it as owed, or it can be money that you earn, because interest can be something that's good. Your money can be working for you and growing for you, or it can be money that you've borrowed and then you're having to pay the interest. So that means the interest is a bad thing at that part. So when you borrow money, or if you use a credit card, because using a credit card is like you're borrowing money from the credit company. And so you end up having to pay interest if you don't pay that off in the very first month that it's used. When interest is earned is when you loan money to somebody else, when you invest money, or if you have a savings account that is earning you interest. The rate is a percent. So anytime you look at the problem and you see the percent, that is the rate. But then I also have to remember when I use it that I have to turn the percent into a decimal before I can actually do my calculations. T is time, and this absolutely has to be in years. If it's not in years, I need to convert it. So if it gives it to me in months, I just have to take it and I'll divide it by 12 to find out how much of a year that is. The other formula we're going to use, and I'll show it to you here, is going to be my balance. My balance is how much money I have in my account. And that's going to be the principal amount, the original amount that I put in, plus the interest that I earned. And so this is my interest in dollars, and this is my interest in percent, if you want to think about it that way as well. So on the back we have the formula, simple interest, and again that's in dollars, is the principal, which is also in dollars, times the rate, which is a percent that we then convert to a decimal, and T stands for time in years. And if I have these three amounts given, all I have to do is multiply. So the first one says, suppose a bank is offering its customers a 3% interest rate on a savings account. If a customer deposits $1,500 in the account, how much interest does the customer earn in 5 years? So I always have my kids do this. I always have them say I, P, R, and T, and then I fill in what I know. Well, I know the percent is going to be my rate that I then have to think of as a decimal. I also can look at this and see that 5 years, well, that has to be my time in years. Now that $1,500, that is the amount of money that I'm putting into the account, so that's what I'm starting with. So that's my principal. So I'm looking for my interest. So remember, I equals P times R times T. So I, in this case, is 1,500 times the rate as a decimal times the time in years. And when I multiply those together, that's going to give me how much interest my account earned in dollars and cents. So that tells me that I earned $225 in interest. Now it asks me to find my balance. So my balance is my principal plus my interest. In other words, the amount of money I started with plus the interest in dollars that I just made. So that means that in my account right now, my balance, the amount of money I have, is $1,725. This next one's going to floor you a little bit, but I, P, R, and T. So true story over here, when you borrow money to pay for college, you have to pay it back, and there's going to be interest on it, and it can be kind of hefty. So over here it says you borrow $10,000. So since that's the amount of money that I start with, that is my loan amount, that is my principal. And it says you pay an 8% interest rate, which you then write as a decimal. And then the last one is in years, so 10 years. So once again, I'm looking for my I. I'm looking for my interest in dollars. So my interest as a percent. When I put these in my calculator and I multiply, you're going to find that you pay $8,000 in interest, which is almost double the amount that you borrowed. So that means when I pay the loan off, when I pay off the balance of my loan, I have to pay the principal plus the interest. So since the principal amount or starting amount that I borrowed was $10,000 and the interest I'm paying on it is $8,000, for that one loan that was originally $10,000, I actually end up having to pay $18,000 back. Yes, that is a true story, and it is as awful as it sounds. So making sure that you can somehow pay off that college as you go is very helpful, or having a very high-paying job when you get out is also helpful. This next one we're going to look at, they don't give us the time in years. They're going to end up giving it to us in months. So in both of these, you'll notice that they give us the time in months. So once again, I'm going to look at I, P, R, and T. So I'm putting $400 into my account, and my rate is 2%, which I then write as a decimal. And my time, since it's 9 months, I'm going to divide it by 12. Which you can think of as 3/4. You can also think of it as the decimal 0.75. So when I'm trying to find my interest, I do the same thing that I did above, only my time in years is a decimal or a fraction. When I do this multiplication, I get 6, and you're like, that's kind of weird. That's been in the hundreds of dollars. But remember, this is only over 9 months, and we were talking about many, many years up here. So that means in 9 months, I have earned $6 in interest. Now, they only asked me, what did you earn in interest? They didn't ask me for a balance. But you could look at that and see that you now have $406 in your account. And our next one over here, it's been going on for 54 months. My principal amount is $5,200. My interest rate is 7.36%, which as a decimal looks really long, but that is correct. And it's over 54 months. When I divide that, I'm going to get 4.5 years. So my interest rate, my amount of interest rather in dollars, is going to be my principal times my rate as a decimal times my amount of time in years. And when I do this, I'm going to get $1,722.24. Now this one actually says find the total in your account. That means that is looking for your balance. So I'm going to add these two up. So my balance is my principal amount plus my amount of interest so that is how much money I have in my account now. This last part down here, we're going to have to find rate or time. So we start with that interest equals principal times rate times time. We're going to rewrite the formula. So I'm going to solve for what I know.